All right, so now we're going to move more into multi-step problems or conversions. Determine the number of molecules of H2O in 12.2 grams of H2O. So we are starting at grams or mass of H2O, right? So that's where we're starting. So on our roadmap, we would be starting here. So right here, we're starting at mass, 12.2 grams, and then we're going to get to the number of molecules, which is particles, right? So we're going here. So actually, it's going to take 2 steps here and here. All right. So our first step will be 12.2 grams of H2O. And then our first step will be to use molar mass to get to moles, right? And so the conversion factor is that 1 mole equals 18.02 grams of H2O. Now, pretty soon I'll stop writing the conversion factors. It's not necessary. It's as good, but it's not. It takes up time. So if I stopped right here, I would get moles of H2O, but I don't want moles, I want molecules. So I need to take the next step, which is the use of Avogadro's number. We know that 1 mole of H2O equals 6.022 times 10 to the 23rd molecules of water, right? So instead of solving this problem, I'm just going to continue and add a second a conversion factor using Avogadro's number. So these will cancel out. And then I'm just going to go ahead and solve it. So I'm going to take 12.2, divide that by 18.02, and then multiply that by Avogadro's number. And I get, now this has 3 sig figs, this has 4, this has 4. So my answer is going to have 3 sig figs, which is going to be 4.08 times 10 to the 23rd molecules of water. Okay. All right, so let's look at the next problem. So the next problem, I'm starting from 8.022 formula units, which is particles, and then I'm going back to the mass. So it's kind of like backwards what we're doing, right? It's going to be a 2-step. As you can see, we have to go through moles. So you have 8.02 times 10 to the 26 formula units of NaCl, right? And we're going to first use Avogadro's number. The formula units need to go on the bottom. Oops, let me write the whole thing. So now I'm at 1 mole of NaCl, right? If I cross cancel my units. So I'm here. Now I got to do another step, which is figuring out the molar mass. So 1 mole of NaCl equals 58.44 grams of NaCl. Now, if you're just watching this and just copying down what I'm doing, it's not going to be helpful. My suggestion is try the problem and then pause the video, try it, and then continue. Because that's probably going to be the most beneficial way, more likely way for you to learn. All right, so 8.02, 21, divide that by 6.022 times 10 to the 23, and then we're ultimately going to multiply that by 58.44, which is the molar mass of sodium chloride. So your answer is 0.7, how many sig figs do we need? We need 3, 7, 7, 8. What are my units? Well, they're right here, grams of NaCl. All right, let's continue. All right, silicon chip used in an integrated circuit of a microcomputer has a mass of 5.68 milligrams. How many silicon atoms are present in the chip? All right, this is going to be really interesting. So we're given the mass, but actually the mass we're given is in milligrams. But if you look at the mass to moles, we have to actually convert that first to grams, and then from there we have to convert. So we want to know how many silicon atoms. So this is milligrams of silicon, SI, grams of silicon. So if you look at the map, we can't go from grams all the way to the atoms. We actually have to figure out the moles of silicon. And then once we figure out the moles of silicon, then we can figure out the atoms of silicon. All right. If you need to use the map, that's fine, but this is how we're going to go ahead and solve it. So starting with 5.68 milligrams, there's 1,000 milligrams in 1 gram. So now we have it in grams, right? I'm not going to solve it mathematically, but I'm in grams. So now I'm here. Now I got to get to moles of silicon. To get to moles of silicon, I'm going to use the molar mass. Remember, to go from mass to moles, you use the molar mass. So silicon has a molar mass of 28.09. It's not a diatomic, right? So it's just 1. So 28.09 grams of silicon is equal to 1 mole of silicon. Cool. So I'm now moles, and now I can go to atoms. I have to use Avogadro's number to go from moles to particles. In this case, it's atoms. Oops, no equal. So I have 1 mole of silicon. Oops, sorry, let me cross cancel. So, cool. So 1 mole of silicon contains 6.02 times 10 to the 23rd atoms of silicon. All right, so let's do the math. 5.68 divided by 1,000 divided by 28.09 times 6.022 to the 23rd, 1.22 times 10 to the 20th atoms of silicon. Okay. All right, let's keep on rolling. All right. In 1 mole of glucose, how many moles of each atom are there? So what I'm asking is, if I have 1 mole of glucose, which is this, how many moles of carbon, hydrogen? So you see how for every 1 mole of carbon, there's the ratio is for every 1 molecule of this, I have 6 carbon atoms, right? So for every 1 mole of glucose, I have 6 moles of carbon. I have 12 moles of hydrogen, and I have 6 moles of oxygen. In 1 mole of ammonium sulfate, so ammonium sulfate is NH4 SO4, how many moles of each polyatomic? So PEI is polyatomic ion. So how many NH4 plus 1s do I have? Well, I have 2 moles, right? And then for every 1 mole of SO4 minus 2, I have 1 mole. What about each atom? So how many atoms are there? There's nitrogen, hydrogen, sulfur, and oxygen. So I have 2 moles of nitrogen, right, because of the subscript there. I have 8 moles of hydrogen, and then I have 1 mole of sulfur and 4 moles of oxygen. So basically you can use the formula to figure out how many, the ratio, or how many moles of each. It's kind of like, you know, a mole is kind of like a dozen. So like if I had 1 dozen bikes, right, and a bike looks like, I don't know, like a bike looks like this. Sorry, I'm not the greatest, but it, handlebar. There's no pedals, I don't like, but anyways, 1 dozen bike. Well, A dozen bikes would have 1 dozen frames, right? And 2 dozen wheels. And so imagine this is like a formula for a bike, right? So for one of these, I need 2 nitrogens, 8 hydrogens, 1 sulfur, and 4 oxygens. So it's kind of like you're just figuring out the parts that are required for the whole thing. Okay. All right. So let's do a problem that involves it. Dihydrogen monoxide, right? H2O everywhere, but not a drop to drink. Calculate both the number of moles in a sample of 270.0 grams of dihydrogen monoxide and the number of hydrogen atoms. So the first thing we want to do is we want to convert moles to, grams, right? So we have grams. We want to convert that to moles. We can do that in one step, just using the molar mass. And then we want to figure out the number of hydrogen atoms. So let's just do the first step first. So 270.0 grams of H2O. We know the molar mass is 18.02 grams of H2O, and that equals 1 mole of H2O. So 270 divided by 18.02 equals 14. We need 14.98 moles of H2O. All right, that answers this first one, the number of moles. But we also need to know the number of hydrogen atoms. But in order to do that, once we have moles, we can figure out the number of molecules of H2O. And then from that, we can figure out the atoms of hydrogen that are in, right? So let's take our 14.98 moles of H2O. So for every let's do it this way. Sorry, instead of going, we can go. So this is moles of H2O, right? So this might be a little easier. So for moles of H2O, we can actually figure out moles of hydrogen, and then from there we can figure out the atoms. There's different ways of doing it. So of hydrogen. Both are fine. I'll show you the other way too, so there's no confusion. But so for every 1 mole of H2O, how many moles of hydrogen do I have? There's 2, right? So in water, there's 2. So that for every 1 mole, there's 2 hydrogen. Now, they're only specific atoms. This is not diatomic, right? It's within water. So now I know the number of moles of hydrogen. But I don't need moles of hydrogen. I need the number of the actual atoms. Well, we can use Avogadro's number. For every 1 mole of hydrogen, there's 6.022 times 10 to the 23rd atoms of hydrogen. And then we can solve that way, right? So if you do that times 2 times 6.022, so you get 1.805 times 10 to the 25th atoms of H. Now, what was the other way that I was thinking? Well, you can go this way if that makes more sense. So I have 14.98 moles of H2O. I could have converted this to atoms of H2O or molecules of H2O, so 6.002 times 10 to the 23rd. This would be molecules of H2O, right? And then in 1 molecule of H2O, I have 2 atoms of hydrogen. So like I kind of just flip-flopped, right? But if whatever makes sense to you, you'll still get the same answer. So you could have gone from moles to moles of hydrogen. Maybe some of you would have liked to go moles of H2O and then gone to molecules of water, and then you know that in one molecule of water there are 2 atoms, you can go into atoms of hydrogen. Both would have worked and got you the same answer. Okay? All right. All right, there's some homework practice if you would like.